Hey guys, so in this video I am going over lesson 3 in unit 6. So in this case we are learning about trig functions and what relationship they mean using our opposite side, adjacent side, and our hypotenuse side of a right triangle. So for sine is going to be our opposite over our hypotenuse side. So what do I mean by this? If we are given a right triangle, our hypotenuse side is going to be across from the right angle, always. And let's say our angle that was given was up here in the corner, which is theta. Our opposite side would be across, which would be right there. So that would represent our sine trig function. Our cosine trig function is adjacent over hypotenuse. So again, we're going to have a right triangle. Our hypotenuse side is across from a right angle. And if our theta is in the top corner, our adjacent side is right beside it. That is not the hypotenuse. And then tangent, lastly, is opposite side over adjacent side. So in our triangle, we're going to have our right triangle. We're going to have our theta that's identified for us. Adjacent side is the side that's touching the angle, but not the hypotenuse, so it would be the one off to the left. And our opposite side is going to be across from the triangle that does not touch the angle. So our trig functions look like this. Sine of our angle theta equals opposite over hypotenuse. Cosine of theta equals adjacent side over hypotenuse. And then our tangent of theta is going to be our opposite over adjacent. So a way to remember this, and maybe you saw it before I went into those boxes, the saying goes, some old hippie caught another hippie tripping on asphalt. So where these letters are coming from is that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So that is one way to remember it. So we're going to use these formulas to find different values. So for the first three, we're finding the value of cosine of x, or sine of a, or tangent of x. So the first thing we want to realize is that we're dealing with cosine. So cosine means we want adjacent over hypotenuse. Another thing we want to realize is that the angle we're looking at is angle x. So we're looking at this angle here. So our adjacent side of this angle is going to be the side that it touches. That is not the hypotenuse. So our adjacent side is 20. Then our hypotenuse is whatever the side is across from the 90 degrees, or the right angle. So it's 29. So the cosine of x equals adjacent side over hypotenuse. And that would be your answer. For the second one, again, first thing I want to realize is that it is sine. So sine is opposite over hypotenuse. Next thing I want to realize is that we're looking at angle A. Angle A is up here. Angle A is going to tell us what is our opposite side and what is our hypotenuse. So opposite side of angle A is the side that it does not touch. So our opposite is 20. Then our hypotenuse is the side across from 90 degrees, which is 29. So our answer is going to be opposite over hypotenuse. And that is our answer. And then lastly, let's try a tangent. So tangent is opposite over adjacent. We are looking at angle X. So angle X is down here. Our opposite side of angle X is going to be a cross that does not touch the angle. So we've got opposite of 10. And then adjacent side of the angle, the side that it touches but is not the hypotenuse, is 24. So our answer of tangent of X is 10 over 24. And that is our answer. So if you will, pause the video and attempt the other 3 on this page. You should have gotten these answers. 48 over 50, 16 over 34, and 8 over 15. Again, if you have any questions, please do not hesitate to contact me either through Remind or through email. So then we go into solving for our angles. So I also wrote it out for you, SOHCAHTOA. Some old hippie caught another hippie tripping on asphalt. So we're wanting to get Z by itself for number 1 on this page. So typically we can do inverse operations to get a variable by itself. Well, we can do the same thing with trig functions. We want to take the inverse of cosine to get Z by itself. Well, to take the inverse, we're going to have cosine of Z. We're going to take that whole thing and take the inverse cosine of it. And what we do on one side, we have to do to the other. 0.8746. So the inverse cosine and cosine cancels out, and we're left with Z equals. And then we put this whole thing on the right side into the calculator. Now, I did a separate video to show you how to put it into the calculator. So you will need to look at that second video if you need help on how to put it into the calculator. But once you do, and you round it to the nearest degree, you get 29 degrees. And that is your answer for number 1. I want to go to number 3. Number 3 is very similar. You want W by itself. So you want to get rid of tangent. So you're going to do the inverse of tan to get rid of it. And what you do on one side, you have to do to the other. 1.7321. Inverse tan and tan cancels out, and you're left with W equals inverse tangent of 1.7321. You put this whole thing on the right side into the calculator, and you will get W equals 60 degrees. Okay, if you will, pause the video and attempt number 2 and number 4. you should have gotten 12 degrees for number 2, and you should have gotten 9 degrees for 4, remembering that it did tell you to round to the nearest degree. Alright, so we're moving on to number 1, where it says find the length of the missing angle, round your answer to the nearest tenth. So we first have to realize, what do we know? We know 2 of the sides of the triangle. Well, if our angle is over here with angle A, we know our opposite side, and we know our adjacent side. Again, this is the adjacent side because it is the side that is touching the angle that's given, and it is not the hypotenuse. So that is why 4 is our adjacent side. So we know opposite and our adjacent. So which of the trig functions use opposite side and adjacent side? Remember, some old hippie caught another hippie tripping on asphalt. Which one has an O and an A? This last one, tangent. So we're going to set this up. We're going to have tangent of the angle that was given, which was theta. And we're going to have opposite first, because that's what comes first in the saying. So our opposite was 5 over our adjacent, which comes second, so 4. And then we're going to solve for our theta. Well, similar to what we did in the last section, we have to get theta by itself, or our angle by itself. So we got to do the inverse operation of it. Well, we're going to do inverse of tangent to get rid of tangent. What we do on one side, we have to do to the other. So we're going to do inverse tangent of 5 over 4. Gets rid of tangent, so we just have theta. And then I have in the same video that I spoke of earlier, I show you how to put this into the calculator. So to find theta, all you're doing is putting this into the calculator, and you're going to get 51.3 degrees. And you are rounding to the nearest tenth. For number 2, we know the side that is opposite. We also know our hypotenuse. So those are the 2 things we know. Opposite. So in our SOHCAHTOA saying, which one involves a H and an O? The SOH part, so the sine part. Again, the first letter tells you which trig function to use, S, C, or T, sine, cosine, or tangent. So in this one, we're using sine. We're going to do sine of the angle that was given, which was theta. Theta is just a variable, if you did not remember that from the previous lesson. Theta is just a known variable that is used for angle measurements. Now in the same, for sine, opposite comes first, so our opposite side was 12.4, and our hypotenuse is second in the saying, so we have over 15.8. We're going to take the inverse sine on both sides. That's 15.8. The the signs cancel out. We're left with theta equals, and we're going to put all of this on the right side into the calculator, and we are going to get 51.7 degrees. A reminder from that video that shows you how to put it into the calculator, make sure you are in degree mode. Every single time that you clear out your calculator, it will revert back to radian mode, and we are not dealing with radian right now. Alright, so if you will, pause the video and attempt number 3, number 4, and number 5. Number 3, you should have gotten 21 degrees. Number 4 and number 5, you should have gotten 46.2 degrees for number 4, and you should have gotten 40 degrees for number 5. So for the practice for lesson 3, you are completing the practice that is found in this packet. So you are doing all of that and trying your best to figure out any misconceptions that you have from this lesson. Again, I'm only an email or reminder